The formation of neutron stars. Everyone must have heard of bomb explosions. They are very violent and cause death of millions of people. Now, imagine, if one of the biggest objects of the cosmos, high-mass stars, explode, then how violent would that be? Stars are so massive, that because of the pressure of their mass, hydrogen atoms combine to form helium, what is now known as nuclear fusion. Just like if you would press two chunks of clay, they would combine. Now, because of their mass, stars also have an enormous amount of gravity, which is pushing them towards inside. But, the force from the nuclear fusion in their cores, is pushing them outside. The two forces stay in balance throughout their life. Hydrogen converts to helium. It builds up in the core until temperature is high enough for helium fusion. Helium fuses to carbon and oxygen into neon, sodium, magnesium, sulfur and silicon, and these fuse to iron and others. But, the stars don't have sufficient mass that they can fuse iron. As a result, nuclear fusion stops, so no outward force is pushing on the star now. The star is now a ticking time bomb. Due to no outward force, gravity wins the duel, and the star starts collapsing under its own weight. While the core continues to collapse, due to some pretty complicated quantum mechanics going on over there, it sends out a shockwave to the outer layers, which blast off in an enormous explosion known as a supernova. It is one of most violent explosions we have ever seen. Now, let's get back to the collapsing core. The pressure there is so enormous that electrons combine to form neutrons. Now, there is a phenomenon called neutron degeneracy pressure. In simple words, neutrons hate being compressed together. This creates an opposing pressure which prevents further collapse of the core. If its mass is 1.4 to 2.8 times mass of the Sun, at a diameter of about 20 kilometers the collapse stops, and the whole mass of the core is compressed in an object of that diameter. It is a soup of neutrons, called a neutron star. It is ridiculously dense, about 1 meter cube of neutron star matter, weighs about 10 to the power 17 kilograms. It also exerts much gravitational pull and also has a very strong magnetic field. You'll have to travel about half the speed of light to escape. These stars are truly one of the most extreme objects of the cosmos.